Hi, we are trying to present Coulomb for you. So we have Newton, Coulomb, and antimatter. And now we are going to, we all remember Newton, his apple, and not so much Coulomb. His electrostatic force may be positive or negative. So electrostatic or electromagnets can be either repulsive or attractive. Coulomb's law is that basically something that is attracting or repulsing is actually directly proportional to the radius between the two forces. So how far away, if something's very far away, a magnet's not going to be able to attract or repulse the other magnet. If it's much closer together, that radius gets smaller, suddenly the magnets can actually repulse or attract. In the same way, Newton talked about mass 1 and mass 2, two forces that actually attract together, gravity attracts together. And again, that key thing there is that the radius here means the radius squared is involved. And then over here again, the radius squared. So the radius, how far apart things are, really does matter in terms of what we actually see happening to those things. So I just need to clear the screen and keep going. Okay. And now, so you can see that they basically are the same law. They have the same kind of law. Now, they're not exactly the same because the size and the relative force of these two is different. They're different forces. So there's gravity, which is the force of things, of planets and stars to each other. And there's electromagnetism over here. And then there's the weak nuclear force. And then there's the strong nuclear force, basically things that these things happen within the actual electron, the atom itself. They have different strengths. So very strong is gluons. The mass of the strong force actually holds the protons and neutrons together. Weak force, very, very weak. Electromagnetic force, photons pushing from one point to another. And then gravitational, the graviton, which is the spin zero. So but 10 to the negative 30 versus 10 to the negative 3 in terms of power, very, very weak. So electromagnetic forces and gravitational forces have similar laws, but gravitational forces are much, much weaker than electromagnetic forces. In the beginning, there was matter and antimatter. Matter and antimatter came to contact. They annihilate each other. So how do we exist at all? Turns out they were thought to be identical except for reversed electrical charge. Neutrinos, having no charge, could either be matter or antimatter. There seems to be an actual preference, slight preference, for neutrinos to become matter versus antimatter, which is why our universe is made of matter and not antimatter. How would they interact? Stop the video, stop the tape and think about it. How would they attract? Would they attract or would they repel? It matters because if they repelled, it would actually explain a lot about our universe. If they attract, we have to explain why the universe hasn't collapsed so far. Enter Massimo. Massimo says that matter and antimatter are both self-attractive, yet matter and antimatter mutually repel each other, which would mean that antimatter would actually be matter in a reverse time stream. So if Massimo is correct, time travel is possible using antimatter. Take home, attraction and repulsion are determined way more by how close you are than way less by how big you are. So mass is not the issue, it's about ratio.